beginning now. Okay, so our topic is microirrigation. So this microirrigations, we have a different name. Okay, so anyone you can say. Sometimes it's called microirrigation. Sometimes it is called drip irrigation. Okay, drip. You know the drip. Drip means when some serious patients, emergency patients, go to the hospital or hospitalized, then doctor gives some drip, we call pushing saline, push the some saline, maybe blood or maybe other things, some medication by drop, is it? So that is a drip. Another name is called trickle. Okay, trickle. Okay, so we have one, two, most widely used these three: drip, trickle, or microirrigation. So the reason is these irrigation systems apply water to the crop very slow, with very slow rate, means very low rate. Okay, low flow rate. Okay, low flow rate. Okay, so this is the main difference with the others, very low, and it doesn't allow water to leave the root zone. You can see this tree. Okay, this is the root zone. Okay, this is the root. So this is the tree, this is the root zone. So meaning that these irrigation systems, when we apply it, when we use it, we apply water only this region, like just in the root. Okay, just in the within the root zone, not below here. No, we don't allow it. This system doesn't allow, meaning that any water leaves the root zone. Let's say this is the root zone, this is the root depth. Any water leave the root, it is considered as excess water or loss. Okay, that's the thing. So now you can see, maybe from this short video you can just simply understand. Okay, so what is the I think there is later you can see. I didn't add here. Yeah, here you can look. Okay, you can see the other irrigation system, so you can compare it when I run here. Okay, this one is a sprinkler. I will come after this, maybe next week. Sprinkler, this is sprinkler irrigation, this is also sprinkler irrigation. Okay, this one is micro irrigation. You can see water is dropping by drop. You can see the small drop. Yeah, this is called drip. This one also micro irrigation system. You can see water is applying to the crop is very low rate, very low rate. Okay, this one is a canal. You can see surface irrigation. So there are some animal is okay, I think floating with the water, so quite a big amount of water. Okay. And there is this one, the right top corner. This is also surface irrigation. It's called, also use lot of water, but if you see micro irrigation system in this one, you can see water is dropping, not just drop by drop, apply to the crop. So our purpose and objective is on depth. You can see here how is Okay, so I think you have understood now. You can see this is the water, so meaning that just we apply water just in the root zone depth. So clear now?
Yes, sir.
Can you see the difference? You can see here sprinkler irrigation, other irrigation. You can see the sprinkler, it applies water entire field. Where it is crop or without crop, like empty space, everywhere they are sending the water. But micro irrigation system only send water in the root zone. This area no water. You can see here, this area no water. Okay, so that's why last time that we studied the crop water requirement. Okay, okay, all right. So that one we can write one way is ET. So if we consider crop water requirement based on climate, so ET is appropriate for micro irrigation system, because we can say ET means what? ET means how much water takes or how much water uptakes by the crop. And we know that crop takes water by root, not from here. If there is no root, crop will not take the water. Water is here, but if no root is here, so crop will not take the water. So crop root is here, almost 95% or 98% roots are here. Maybe some few roots can move here, that is negligible. Okay, so we will consider most of the roots, those are accumulated within the small area. Okay, so in that case crop water requirements equals to ET. I think this is appropriate, you can use it this when we consider climate based. Okay, and another crop water requirement formula that I provided you, okay, that is called, okay, crop water requirement, sometimes we call net irrigation requirement. Okay, so now if I write, you understand, because previously I discussed. Okay, so what we used the field capacity minus permanent wilting point. Okay, so divide by 100. Okay, so then you can review it. Okay, but if you use the decimal form, if you use the decimal form, meaning that FC is, sometimes this FC we can write like this, theta FC. Okay, theta FC means moisture content at field capacity. Okay, so if you write like decimal form like this, then you don't need to divide by 100. But if you write in like in percentage, percentage, then you have to divide by 100, because in the formula we use the decimal format. Okay, and then permanent wilting point. So permanent wilting point, sometimes in the book you can find this theta PW. Okay, so both way is correct. Either you can write field capacity or like this, or maybe like this. Okay, correct. Okay, then you can see previously then I explained in the formula that we use, after this we use the DRZ. Okay, what is the DRZ? DRZ is the depth of root zone, is it? Depth of root zone. So meaning that micro irrigation system is very appropriate, because in micro irrigation system we use water only in the root zone. So meaning that from the surface to the root depth, this is the depth. Okay, so this is this one. All right, then we used another one, we use the MAD, is it? I think you can recall now. We use, I called MAD, sometimes it's called okay, is okay, maximum. Okay, MS, maximum soil water depletion. Okay, MSWD. Okay, means maximum soil water depletion. Sometimes we call maximum soil water deficit, and this one is called maximum allowed depletion or maximum allowed deficit, is the same thing. Okay, these both same. So different people use different thing. Okay, but it is the same. So last time we used the MAD. What is the MAD? I think you can recall, but I just touch it. MAD means this is the field capacity, all right, and this is the permanent loading point that we used here. And MAD is your decision, meaning that when you will irrigate again. Okay, so one decision is when we supply water, we supply until field capacity. That is clear. But when next irrigation? Is it, let's say our field capacity is 32 and wilting point is, let's say, 12%. So meaning that our available water is 12 to 32. Any percentage, okay, is this. So now is your decision when you want to supply water. Like you take the breakfast, then we take the lunch, we take the dinner, but we don't take the same time. It depends when I feel or when my time is available. Not only when I feel hungry, also my time, is it? So this is some decision. So decision based on some factors. Okay, your time, your water availability, and other maybe other things. So maybe you can decide, okay, my next irrigation is in between this anytime. Okay, so normally, as I mentioned before, it is normally 50% in between, or maybe 60%, but you can quantify, okay, that I mentioned before. So let's say in this case, I just for simple understanding, and I want to skip it quick. Okay, so let's say we consider what is this 32 in the in between is 30, 12 is 20. So maybe let's say 18 or 12 means 20%. Okay, so meaning that when crop receive the full water, so it reach to field capacity. Okay, field capacity means it is 32. Then we decided MAD is 20%. So meaning that somewhere here. So meaning that when moisture content is 20%, we will decide to irrigate. Okay, so meaning that this water will not completely, okay, finished, means some water will retain in the soil. Okay, so before before reaching to okay, permanent wilting point, we will supply water. So that decision you can say 20%, maybe you can say 16%, but before 12, because when it will go 12 or close to the 12, crop will go under stress that I mentioned before. Okay, like this. Can you remember this kind of curve? Okay, something like this. So MAD should be this point, so that moisture content in the soil will not allow any reduction of yield. Okay, so if we can consider, that's why it is called theta c. It's called critical moisture content. Sometimes this critical moisture content should be equal to the MAD. Okay, so if we can quantify MAD with the critical moisture content, that is the best and right decision. Sometimes it can be slightly difference before and after, but it should not be much problem. But this is the right and best decision, because if we can maintain MAD at theta c, so meaning that this condition, so our crop will never okay, will not means this management system will never allow any reduction of crop yield, means we will get the maximum yield. Okay, once moisture content will moisture content in the soil will come below theta c, we will get some yield reduction. I don't know how many percentage, maybe 5%, 10%, different percentage. So that is the principle. So that's how we use the MAD here. Okay, all right. And then, okay, I need to erase this one because I have to write something here. Okay, so this is theta c equals actually same as MAD. Okay, I can write here this MAD. Okay, so when you that is a formula that I used before, is it? I think everybody is clear now. Am I right?
Yes, sir.
Okay, now because we use microirrigation system, so we have to add additional. Okay, so what is this additional? Okay, now you can look. This additional is called PW. Very simple item, one parameter. So PW is what? PW is the I discussed before just once. Okay, I didn't discuss much. Just told that this is need to apply. Okay, so I will now I like to discuss details about this. Why we use PW? PW is called percentage of weighted area. Okay, percentage of weighted area. Otherwise, you can say percentage of irrigation area, irrigated. Okay, not weighted. You can say irrigated. Okay, irrigated area. Why this one? Because previously we used this one for entire area. Because in micro irrigation system we don't apply water this area. You can see, you can sit here, no problem. Okay, nothing will happen to you. You will not touch any water. You can sit here, this place. Okay, you can sit here. No problem. You can discuss with, because this is the orchard. So you have a 2, 3, 4 meter wide. So you can walk here. You can discuss. You can play. Should not be problem, because this area soil is dry. Only we supply water here. So now you can see, if you compare this, then how many percentage of area you are applying? Okay, compared to from here. Let's say if I consider this area, this area. Okay, this area. Okay, so this PW is like, because previously we consider entire area. So that time when we use this formula, we said that PW is 1 or maybe 100%. Okay, if we say 100%, so meaning that PW is 100 divided by 100, so it is 1. Okay, if we write in percentage, it is 100%. If I write in decimal, it is 1. So this one is for like sprinkler irrigation and other irrigation. But when you use the micro irrigation system, PW is not 1, because we supply water only this part. Okay, so how to find it? So we need to find this PW. So PW is, then I just write here, PW equals okay, area of one plant area. Okay, is this called planted area or one plant? Okay, divided by okay, area of the, okay, this is actually called not W actually. I think you can confuse. Okay, if I put the P here. Okay, so maybe I can write area of weighted and area of plant. Then you can find. Okay, how to find it is very simple, because when we use this crop, you can see we have two things. Okay, I remove this thing here. Okay, then I have to write something else again. Okay, then you can understand. There are two things here very clear. One is we call plant to plant distance. Okay, like this. What is the distance from? Okay, so this is not the plant to plant. This is called row to row distance. This is called row. Row means like this direction. You know, the one row, the 1 tree, 2, 3. So maybe in the row you have many trees. Okay, so this is called row. Okay, this direction is called row. Okay. Okay, so this is the one, this is the first row, and this one is the second row. Okay, this is the second row. So second row, this is the first row, this one is the third row, if we consider like this. But when, so meaning that this is the row to row distance, so this one is called row to row distance, we call r to r. Okay, means row to row distance. So this row to row distance you can calculate, not calculate, sorry, you can measure it by the measuring tape. Okay, let's say it is a 4 meter. 4 meter. Another distance is called plant to plant distance. You can see this plant to plant distance. Okay, so this one we call plant to plant. So plant to plant distance. So plant means when you plant any crop, okay, something like this. Let's say this is the line, and you want to plant. Let's say first plant is here, second plant. So let's say what is the distance? So you can have a many. Okay, many. Okay, so every, let's say every 3 meter. So meaning that every 3 meter. Okay, meaning that this plant. So this is every 3 meters you grow, you plant one tree. Okay. So this is called plant to plant distance. Another is called row to row distance. Okay, so this AW, okay, AW is, okay, I remove this one, this part is not necessary now. Okay, AW is then AW AW is area of this. Okay, area of this. So meaning that when you apply the water, you can measure this width, and then you can know what is the root zone depth. So this is the dr. Okay, dr. This is the one way you can maybe find. This one maybe b, this one maybe ace. Okay, so maybe b multiply ace. Okay, width and height, you can find the area of irrigated area. But in micro irrigation system, when you calculate the AW, you will find with some information. Okay, because micro irrigation system is a small emitter. You can see it here. When water is supplying here, I will show you later, there is a small device like sprinkler. You can see the sprinkler, water is applying. So here is, there is a one device here, every place has a device. So this device has some characteristics. So one of the characteristics is DW. Okay, one of the characteristics is DW. DW means weighted diameter. What is the weighted diameter? So this is the diameter. This is called weighted diameter. All right. So this information you will find from the emitter. So when we buy the emitters, the manufacturers will give this information. Otherwise, maybe you can buy and then you can test in the field. Then you can see, let's say you operate for 1 hour. After 1 hour, what is the weighted diameter? Okay, so you can find it. So this is called DW. Okay, this is called DW. So DW will be given. So if DW is given, then you can find the area. This is called pi DW. We know that this is the area formula. If we something, if is a diameter is given, we can find the area DW. So you can find this AW either this way or this way, but most widely practice is this one, DW. All right. Okay. So clear now. AW. What is the AW now? How to find it? Okay. Next, AP. What is the AP? AP is very straightforward. Okay. AP means plant area. Planted area or plant area. Let's say one plant. How much the area? So that area is, you see, I just now explained, RR means row to row distance. row to row distance multiply by plant to plant distance. Plant to plant distance. So then let's say this one is 4, this one is 3. So answer is 4 multiply 3. So it is 12 meters square. So this is, so this one is AP is 12 and here is, I don't know how much, maybe 6 or 8, something like this, or maybe 7, okay, maybe 8, something like this, okay, or maybe less. So you can find the percentage. So this PW you have to use here, or maybe it is not 8, maybe 4 or maybe 5, okay, 4 by 12. 4 by 12 is how much? 4 by 12, it is around 30% or maybe 30-40%. Okay, so usually 30 to 60%. Okay, most of the cases, most of the crops will be within this range. Okay, 30 to 60%. So this PW then you have to use here. So PW same, if you use percentage, let's say if it is 30% or 35%, so means PW equals, when you write in the formula, you can have a two ways. One is 30, let's say 33%. Another way is in the decimal format. Okay, so when you use in the formula, if you use percentage, so divide by 100. Okay, so this is the additional thing only, otherwise everything is same. So clear now? So when you use crop water requirement, when you calculate crop water requirement with the micro irrigation system, crop is same, because this crop you can irrigate by micro irrigation system, you can irrigate by sprinkler irrigation system, no problem. You can use also this irrigation system, should not be problem. But when you do it, so then crop water requirement will be different. So okay, this is the thing. So clear now? If you have any questions, please, I will explain, then I will move to the next. Any questions? No question? Anyone?
No question, sir.
Okay, thank you very much. So this is a micro, but when you use the sprinkler, like you said, the left one, so same thing, we can use this, otherwise we can use this, but this section for sprinkler irrigation, this will be 1. It 1 means we don't need to write this. Okay, all right, we can use also other irrigation system, because other irrigation system we apply water everywhere. Okay, so that's why we use 1. Only micro irrigation this. Okay, so clear now. So as I mentioned that any irrigation system, when you want to apply, when you want to design, or you want to do some irrigation scheduling, when you want to develop the irrigation scheduling, okay, or you want to supply the water, so first thing that you need to do the crop water requirement. So this is the crop water requirement. Okay. Okay, so this one you have seen already. Maybe here is picture is clear, little bit wide, so you can see the rules. Okay, and it is a normal practice in micro irrigation system. We use this called row, the plant, okay, planted in a row, systematic order, and then row to row distance. That means from to here to here. This is a row to it is the same, should be the same. Okay, should be the same. And micro irrigation system doesn't accept, let's say we grow one crop here, after this another crop. No, it should be the same crop. Okay, so should be the same crop. Okay, I have given some YouTube link sometimes, so maybe you can watch it like this one. Okay, then you can see very nice pictures, nice videos. Okay, and this is the another one that I mentioned before, netafim. So actually this is the microirrigation system under the shade. Okay, so it looks like very nice structures. So you can use here all the technologies, computer, electronics, sensors, everything you can use. That's why this is called smart actually. Okay, so that's why this system is called smart irrigation systems. Okay, so actually micro irrigation system is a very actually micro irrigation system itself is a smart irrigation system. Okay, but we use some device like computer, electronic sensors and other things just for monitoring, purpose. Okay, because monitoring means anytime we can know about our crop, how much the moisture content, what is the growth, okay, what is the fertilizer level, everything we can know. But our purpose is irrigation. We don't study like fertilizers or other things. Okay, but all information you can find it. Even if you like to study the nutrient level, different nutrients, is it NPK or other things, you can monitor, no problem. Okay, so this is the micro irrigation system. You can see the quite a big areas. So this is the inside. Okay, and you can see that inside if you have everything like our human use the air cone. So here you can see also air cone, fan. Okay, why we need this air cone, fan? Because crop needs some optimum temperature, suitable temperature. So if our temperature is high or very low, so in these structures we can maintain that temperature for the optimum growth. Okay, you can see the structure is very closed, so meaning that it is a closed means like our building, our room. Okay, so climate or environment is maintained artificially with air con, cooling system, exhaust fan. Okay, then airflow. Okay, so everything is there. Then sensor, this because this is the micro irrigation system, you can see. Okay, so this is the box, you can see one box, one box. Okay, this is the another box. So meaning that this is the plant to plant distance. Okay, and then if you go to the next row, this is called row to row distance. So how they arrange. Okay, all right, so this is indoor, but you can grow in the outdoor also, both. Okay, so now I come to the pressurized irrigation system component. Okay, so I discussed both during when I discuss sprinkler irrigation. Maybe I will not discuss again this thing. Okay, so pressure, when it's a pressurized irrigation system, so actually it is micro irrigation and the sprinkler irrigation system, these two. So today our topic is micro irrigation system. So micro is like this and sprinkler is this. Now you can see the differences. Difference is not much actually. You can see I use the same pictures almost. You can see here, this is the water source, this is the water source, and then you have a pipe, you have a pipe, and you have the pump. Okay, in the pump you have the pump here, this one, pump. So meaning that water source and pump. Okay, so micro irrigation system or pressurized irrigation system, we must use the pump, because otherwise we cannot create the pressure. You know, we need to create some pressure, means water will flow under pressure or with some energy. Okay, pressure means in this case actually energy level. Okay, like water in the pond, it doesn't move, it is quite okay, very calm, or maybe why just call standing or ponding. Okay, it doesn't move because the level in the pond is like this at the different depth. but the water level is the same. Okay, it's not like this. Okay, if like this, so water will move, because water never stay like this. Water always try to maintain the equivalent depth. Okay, equivalent depth means equal depth. Okay, so that's why in the pressurized irrigation system, when you use the pump, the here is energy is very high, that I mentioned before when I discussed the hydraulics. Okay, hydraulic topics, that's why I discussed. Okay, at this point when pump, because pump create the energy, when you start the pump, you can say it uses some fuel or electricity, so meaning that it gives some energy. Like our car, when you start, it uses fuel or gas or whatever energy, then it produces energy, or create power, is it? They use fuel and create power or energy. Similarly, pump is here. Okay, use energy, sorry, use fuel or gas or other things or electricity, and produce the or create the power or energy. Okay, so this is the power, or maybe we can say energy. Okay, so meaning that energy is very high here, but at this point the energy is very low in the field. Okay, but this one has a connection, you can see the pipe. Okay, all have connection. So pump when pump supply water, here energy is very high, so water moves through this pipe until where is the low energy at the end, where is our plant. Okay, so that's why water comes slowly by this pipe. Okay, so due to the energy difference. Okay, so that's why both system uses pump, micro and sprinkler. And then there are some other things you can see here, this one and this one, but in the sprinkler irrigation it is not available, it is not necessary. But micro irrigation system, we must need it, this thing, this some additional thing, micro irrigation system. This is called filter, water filter. Like our case, we use the water filter in the house. If we don't use the water filter, what will happen? Some dust or dirty or some small particles will come, is it? Then it will go to our stomach, so we don't accept it. So similarly, micro irrigation doesn't allow any sediment, so we need to use the some filter. So normally we have a two types of filter, one is primary filter, another is secondary filter. Sometimes depending on the water quality, if water quality is good, means here source of water is good, maybe you can use only the primary. Okay, primary filter. Okay, but if water quality is not good, maybe water has some particles we can see, then we have to use the primary filter and secondary filter. Okay, there are some other things also we use, we call injector. Injector means injector. Okay, okay, filter is everybody is familiar. Okay, injector is a chemical means, let's say, fertilizer, insecticide, pesticide, because sometimes if crop has some disease or pest, there are something, if we want to control, so we use the injector means there is a device, so that device we use the fertilizer, insecticide, pesticide with the water, so that chemicals comes with the water and directly apply to the crop, not like spreading. You don't need to spread throughout the, because if you spread, so we will drop here, we will drop here, but there is no crop here, that is not effective. So that's why in the micro irrigation system we apply fertilizer, insecticide, pesticides with the water, so it comes through this pipe and this, and directly apply to the root zone depth. Okay, you can see some shadow. This shadow is called weighted area, that I told you before. We use the DW, is it? This is called DW. So if we know the DW, then we can calculate the AW, weighted area. And P is like this, plant to plant and the row to row. Then we can get the AP from here. Okay. So AW divided by AP is, then we can calculate the percentage of PW. Okay, AW, sorry, AW and AP means planted area. So this is the shadow. You can see each plant has the shadow. You can see all the shadow are same. Okay, this automatically created. Okay, I'll show you later how. Okay, so this is AW, so meaning that you just take the diameter, you take the scale and measure this one. Okay, that's all. This is called AW. So AW. AP is, as I mentioned, plant to plant and the row to row. So this one you can divide, you can measure by tape, you can find, so you can find the PW. Okay, okay, so this is the same, only the, but sprinkler irrigation you don't have this. Okay, anyone can tell me, do you have any idea why micro irrigation use this thing, this filter and this injector? Okay, this is the injector, but usually sprinkler irrigation doesn't use it. Why? Do you have any reason? Anyone? Just guess. I will give the answer, but I just want to know whether you know or not. Can guess or not? Anyone?
So that it doesn't block the sediment doesn't block it
Sorry?
and cause rupture.
Anything?
The sediment can cause rupture if no filter.
Sediment? Again, please. I'm not
The
clear.
sediment, if too many, if since it's pressurized,
Yeah.
it can cause rupture.
Yeah. Okay. Yeah. That's the answer actually. But there are few answers. Okay. This is true. This is suitable for everyone. Meaning that if sediment with the water, so when it flows to the pipe, so it can deposit. It can cause the some difficulties or damage. Okay. Or it can block actually. Okay. All right. Block, because you can then it can block actually. All right, the main difference is the water in the micro irrigation is very low pressure, but for sprinkler irrigation is very high pressure. Okay, means water moves very fast. Okay, very fast with the high pressure, because here is pressure is very low, very less amount. Okay, less amount. When water flows here, Q is very small amount, but here is high amount. So what is the Q? I just give you the one example. Like micro irrigation system, the Q is, okay, Q means here. I tell you here, because each plant there is a call one device. Each plant there is one device. Like here, okay, here is you can see the one standing. This is called sprinkler. Standing with some pipe, maybe 2 meter 3 meter height. Okay, so this is a sprinkler. Yes, sprinkler you can see, but in micro irrigation system you cannot see. But micro irrigation system you can see when you go to the plant, then you can see at the bottom you can see some white thing here. You can see this one, there are some white thing. So this is a small thing. I have a picture later. So this device supply water, the flow rate is like this, 1 to 8 liter per hour. This is the maximum. The range is 1 to 8 liter, meaning that if you run the system If you run the system, means you run the system from here. If you run the system for the 1 hour, you can apply maximum 8 liter. But here, if you run, you can apply few hundred liter. Volume of water is high. So if you know the volume of water high means the pressure will increase. Okay, pressure will increase. All right. So that's why micro irrigation system, you need the filter, because it is a low pressure. It is pressurized but low pressure. And sprinkler, it is a pressurized but it is high pressure. This is the difference. So when water with the high pressure, so the sediment cannot stuck here. This is called sprinkler nozzle. Okay, sediment doesn't stuck, but if some particles there in micro irrigation system, it simply can stuck here and it can block. Okay, it can block because very small, narrow, very tiny opening. This one. So that's why micro irrigation system needs filter, maybe primary filter, maybe this is called primary filter, this is secondary filter, and also need the injectors. Yeah, but sprinkler, it is not necessary. Okay, an injector, because micro irrigation system, it recommends to apply fertilizer with the water, because then you can apply the direct to the crop, because this area no crop, you cannot simply spray by hand or machine, then it is wasting. Okay, so this is the reason. Sprinkler, because apply everywhere, so you can just spread your fertilizer chemicals by machine or by hand throughout the field. But if you like, you can also use by sprinkler also, means fertilizer, insecticide, liquid fertilizer and liquid insecticide. You can use also the water, because when it comes with the water, it drop with the field. Both techniques you can use. So this is the main difference with the micro and sprinkler. So both are pressurized irrigation system. That's why I write pressurized irrigation system. One is low pressurized irrigation system, another is the high. Micro sprinkler is the high pressurized irrigation system, and micro is low pressurized irrigation system. Okay, this one. All right. Okay, there is another one, like land like this. If your topography is like what called undulating, you can see here, if I draw line, okay, so meaning that it is not horizontal. This is the difference between the elevation, is it? Every place is the elevation differences to here. Okay, then now let's say if I ask you to irrigate this crop, this crop, this crop, this crop, you can see the plant. This is the plant they have planted. So which irrigation system is suitable for this, from your understanding now, what I have explained? Anyone? Which irrigation system you recommend? Micro irrigation system or sprinkler? Which one you recommend? Or maybe which irrigation is suitable? Anyone? Yes, this is micro, because sprinkler irrigation system, as I mentioned, why there is two reasons. Okay, micro irrigation system is, I said, low pressure. Is it low pressure? I just write in short form, low pressure, then low flow rate. Low flow rate means low Q, low discharge. And sprinkler irrigation is a high pressure pressure is high. Okay, so this is high pressure, and Q is also high. Q is also high. So if you, let's say if your land is like a sloping, and if you apply high flow, okay, high pressure and high flow rate, okay, high flow rate, and here is low pressure, low flow rate, okay, low flow rate. So meaning that if you apply more water here, so what will happen? Then water will move down like this. So that is a sprinkler. So if you apply, if you use sprinkler irrigation, this thing will happen. Means you apply, actually you need to supply water here. But if you use sprinkler, the water is supplying, then water will come. This is the tree, then water will come to here. Then it will drain out, wasting. All right. So this thing will happen. Okay. But when you use the micro irrigation system, how the micro irrigation system apply water in the root zone depth. So meaning that when we apply the device with the pipeline, so you'll put the emitter is called, this is called emitter. Okay, micro irrigation system, that device that used to apply water, it is called emitter. Emitter is a device that inject or apply water to the plant. Okay, so we have to apply just at the plant. This is the place we will install. Okay, maybe we can have a pipeline like this. We just run the pipeline like this. Okay, so every place we have emitter here, we have emitter here, we have emitter here. Then plant to, and then emit when we run the pump. Maybe our pump is somewhere here or anywhere. Maybe this water is coming, so it will drop the water just by drop. Drop means like this. Okay, this called by drop. Water will apply drop. So when you apply water by drop, okay, so this water will not move like this, runoff. There is no runoff. The soil will hold. You see, last time I told you holding capacity. What is the holding capacity? Holding capacity means what? Field capacity to PW. Okay, or maybe field capacity to your MAD. Because we don't supply water after field capacity. We supply water until field capacity. What is the field capacity? Last time I explained, you take the one bucket and you soak some cloth and hang it. Then you can see the water is sipping or dropping, but after sometimes there is no water is dropping. Okay, water will stop. So meaning that cloth can hold some water. This is called holding capacity. So similarly, every soil can hold some water. So when you apply drop, so water will not move. So soil will hold. So soil will hold water until field capacity. So when moisture content will be more than field capacity, then only water will move. But in micro irrigation system, we don't apply water after field capacity. That's why this type of land, or means undulating or hilly areas, it is not suitable to irrigate by other irrigation system. Only micro irrigation system is the best. Okay, you can use other system, but notice that is not recommended. Okay, this is the reason. I hope everyone is clear now. Okay, we move to next. And yeah, this is maybe the another issue in the global. We have this issue. I think I showed this slide before. We have a 10 billion people by 2050. Agriculture production need to increase by 50%. Okay, because our land is not increasing. Land is day by day is decreasing. Okay, agricultural land, because we use the industry, we use the houses, so meaning that agricultural land is decreasing day by day. So way to feed the people is we have to increase the production. Okay, then water also will reduce available water for agriculture, because people in the world is continuously increasing, so they need water. Then they build the industry need the water, so meaning that where they will get the water is a fix, just water moving one place to other place. So we need to improve the efficiency. Okay, so meaning we will have a less water, so meaning that we need to grow crop with less water. We have to, means that condition is called, we need to grow, what I say, grow, we need to grow more crop. More crop means maybe 50% more by 2050, because population will increase. We grow more crop with less water in future. Okay, so we have to prepare from now. Okay, water, why water? Because in future by 2050 water will not be available at right now. So this is the condition. In this case, if we want to satisfy this goal, if we want to achieve this goal, so one of the technique is a micro irrigation system, or maybe pressurized irrigation system. Okay, sprinkler or micro. Surface irrigation system would not be recommended in the future because the efficiency is very low. Surface irrigation system, last time I told you, the efficiency is maximum 70%. 70% means very nice irrigation system, but micro irrigation system is efficiency is up to 95%. Sprinkler is also 80 to sometimes 90% can be, but easily maybe 70 to 80. Okay, but sprinkler can be like 80 to 90 general, but the best it can achieve 95. Okay, so when we have a high efficiency, so we can minimize the losses. This loss we can reduce. So when we reduce the loss, so meaning that we can use less water, and then we can grow more crop. We have to use some technique. When we apply good technique, good management, we can improve the yield. Also some the varieties, different varieties, okay, also can increase the yield. So that is the goal, national goal or global goal. So we need to achieve it. So for this case, is micro irrigation can play important role. Okay, this is the thing. So we have a different system, so that you can you have listened before maybe, or maybe you have seen. You can see sometimes now the YouTube, you just search it, aeroponics, deep water culture, drip irrigation system, nutrient film. So these are the systems now using. Okay, so this is the pipe, the grow in the pipe, the water irrigate from the bottom. This is the floating water in the plant, so take the water. Nutrient film means the water is with the fertilizers, and then plant can grow. Drip irrigation, that micro irrigation system is the same like this. Okay, all right, so most of the things I have already discussed here, that system, this is a micro irrigation system what we have. Okay, all right, like this is water is applied by drops. Okay, i I mentioned already. And when water applied, located, you can see on the soil surface, beneath the surface, just below the surface, or maybe in the root zone depth, in the root. Okay, that's all. Okay, so micro irrigation system, we have a different layout. Okay, because we have a closely grown crops like vegetables, because vegetable grows very close. Okay, like this, carrot, cabbage, cauliflower, this kind of crops, it planted very closely. So usually we leaves cover the areas. Okay, here. All right, and there are some like corn like this one. Okay, is planted something like maybe 15 centimeter, 20 centimeter plant to plant, and then distance is here, because we need to keep some distance, because otherwise you cannot move. We need to do some farm operation. Okay, so we need to move, so we have to keep some. So normally this one is a 0.75 or maybe 0.75 meter, and plant to plant is something like 0.3 meter or maybe 0.2 meter. Okay, so this is the thing. Okay, so and this one is a orchard, like fruits, lemon, this kind of things. Okay, so this one has a plant to plant distance, and we have a row to row distance. Okay, this is a papaya, is same. So this is called plant to plant distance, this is row to row distance. So then each plant, when you know this, so this plant to plant distance, you can, if you know the plant to plant distance, so meaning that plant to plant multiply by row to row. So this way you can find the area required for each plant. Area required for each plant. This is called AP. Okay. Another one I told you, AW, is it? AW means weighted area. So weighted area is determined by DW. DW is emitter. As I mentioned, the emitter. So DW is the emitter weighted diameter. So this one, when you buy the emitter, so emitter will give you this DW specification. Okay, then we can calculate pi d square by 4. Okay, this is the thing. Okay, so this is the root zone depth. Okay, we can see. Then micro irrigation system and another system, we can see the pipe here. Okay, so this is actually we can put this pipe and this pipe on the surface, but this pipe is the underground. So this pipe is the surface. You can see both are cone. This is cone, same, but this one laid on the surface, this one is underground. You can use both. So this is called temporary system, this is called permanent system. This one is good because it is easy to move the machineries. Simply you can see, if you have a tractor or some machineries, you can simply move, there is no problem. But here is a problem, because you cannot cross like this. You have to come like very carefully. If your machine or tractor run over this, the pipe will burst. Okay, so in that case, this is a good. So this is the difference. This is called surface, but the same pipe, it is underground. Okay, or you can lay it like this. So this is called layout of the pipe. Okay, so this pipe is what actually this pipe. If you previously that I showed the picture here. Okay, this pipe. Okay, so this pipe or maybe this pipe. Okay, okay, so this pipe you can put in the underground. Okay, or maybe you can put in the surface. Okay, like here. So this is the pipeline, so you can put in the underground or you can put on the surface. Both is available, because water remains under, water comes with pressure, so somehow water will come here. Okay, like your tap in the home. Okay, when you close your tap, water will not drop, but once you open, water will drop, because pressure difference to the source and your house is different. That's why water moves. Okay, so that's why micro irrigation system and sprinkler irrigation system, it is underground or over the surface, it doesn't matter. Okay. Okay, another thing that you need to care about, soil type. Okay, you can see the clay soil. If you use the same device, you can see the device here, this device, this called device, this device supplying water. Okay, they apply the same amount of water but different soil. So what happened? Because last time I told you the water holding capacity, each soil has some capacity to hold the water. Okay, so clay soil has more capacity. That's why when you supply water, you can see the clay hold more water. That's why it doesn't move vertically faster. But sand soil, sandy soil, when you apply water, it moves vertically. It moves vertically faster. But this one is almost, you can see, almost the same. But clay and loam soil, vertical movement is slow, but it spread left and right like this. It is almost, we consider like a circular. Okay, it is circular. It is, if it is uniform soil, it is like this circular. That's why we use this DW. Okay, either here or maybe this one on the surface. We use this one as a DW. Okay, and this is deep, this is because of, you know, the field capacity minus permanent holding point. You know that in the clay soil, this one is higher. Okay, this one is higher. Difference between this is higher. That's why water can hold more. Clay, loam, but sandy soil is low. So that's why it moves faster. Okay, so this is the one thing you can consider. So in that case, you can see one very important factor. So when you use what is called, let's say you have a field. If you have a crop field, and your soil is sandy soil. Your soil is sandy soil. So which system is a good? Micro irrigation system is good because micro irrigation system apply water by drop, very slow amount. So water will not move very fast. But if we use sprinkler irrigation, the flow rate is very high. So once we apply it, water will move very fast. So if your sandy soil, micro irrigation system is very useful. Okay, than other system. All right. So that's why when we apply the crop, we have to look what is the crop, what is the topography of the field, what is the texture of the soil. So all of these things actually you need to consider. After considering, then we can find the best system, either micro or sprinkler. Okay, you can see the one problem here. This is not a micro irrigation, this is not a sprinkler irrigation, this is a surface irrigation system. Surface irrigation system is water supply from the one end. Let's water supply from here like this. So this system is like this. Okay, usually there is a, you can see here this line. Okay, maybe there is some line here, or maybe here I can put here. Okay, so water is coming from, let's say, this side, and water moving like this, and then you have here opening some device. So when you open the gate, like our tap, our house tap, so when you open the tap, so water will move. Water will move here. Okay, so this is called surface irrigation, but it is called furrow irrigation system. So water moves from here, and this water will go until the end. Okay, this is called surface irrigation system, and then you can see the soil is wet, left and right. Okay, soil is wet. So what is happening? So it's something like this. Like this. Okay, if I draw, so this is the water here. This is the water here. Let's say this is means this one. Okay, this one, and this one is also have water here. This one means, let's say this one, water here, and when you supply water here, so water will shifts like this. Water will moves horizontal and vertically both way. Okay, because the soil has some porous, some spaces. All right, so water will move, and when water moves left right, also water will move vertically. Okay, both ways. That's why you can see here water moving left and right. When water moves left and right, and there is a crop here, and crop has the root, and then water will reach to the root. This fine. Water is this, we can irrigate the water, but same times we have a lot of water that leaves the, it goes to the deep percolation from here, this area, it deep percolation loss is very huge. You can see here. Okay, this is the root. Let's say this is the plant, this is the root. In micro irrigation system we don't allow water, this water comes here. No, we don't allow it. And micro irrigation system is, if we use micro irrigation system here, not this furrow, so we'll put the pipeline here, stair pipeline. So we apply water here, and water will just supply until this. Water will never come down. Okay, so meaning that we can maintain the same water depth everywhere, because micro irrigation system, it water goes to the pipe and supply everywhere same time. But here water entering from this side, and water is always here. More water is here, then water moves slowly. So this area is highly irrigated. That's why water moves down here. You can see, and the end it is low amount. So and the end is low. So this amount of water is lost. This area. Okay, so this is the difference between the micro irrigation system or maybe sprinkler irrigation system with the surface irrigation system. Okay, so this is called adequacy. I think I discussed before adequacy. If not, maybe I will discuss again. Adequacy of irrigation system. Adequacy means what? Let's say you are a how many students? 14 students. Is it? 14 students. 14 students. So let's say 14 students. You buy some fruits or something. Okay, then you want to distribute. Okay, distribute. If you pack it and weight it before, that is okay. But I'm not asking like this. I'm asking like, you have a rice here. This is not rice, and maybe here you have a some. I just give two example. One is rice, another is maybe some chicken here. Okay, chicken, and here is some juice. Okay, I think juice is okay because if you have a glass, but in this case it's not like this. If it is juice here, and every student has a glass. Let's say this is your, this is all of you are sitting here. Okay, you are here, another is here, another is here. Okay, and if I ask someone, and every one of you has a glass. Okay, glass. If I ask you everyone, someone, okay, just go and give the juice here. If you fill the glass completely, it's okay, you can control it. Okay, it's easier. But if you have a plate or something, then I say, okay, give the rice to them. Okay, if you have some measuring some small spoon or something, then you can give equal amount. But if you use just randomly, nobody will get the same amount with a different amount. So that is the micro irrigation system, and other means this system. So micro irrigation system use the special device, so that device use the right amount of some amount of water. Okay, because microirrigation system, when you use the microirrigation system, we use the emitter. Is it emitter? So emitter flow rate is fixed. When you set up the emitter everywhere, okay, let's say emitter is flow rate is 2 liter per hour. It meaning that if you apply water here for 1 hour, every emitter will take only 2 liter. It will not take more water. Everywhere will be the same. That's why by micro irrigation system you can maintain the constant depth, but other irrigation system you cannot do that. Okay, so that's why other irrigation system adequacy is not good. Adequacy means each crop should receive same amount of water, but you can see here water is more, here water is less, here is small. So different crop, different amount. So adequacy is low or very much difference than micro irrigation system. So micro irrigation system can maintain high adequacy. All right, micro sprinkler. Okay, I will show you how to calculate it later. Okay. Okay, so this is that's why micro irrigation system is very important. Okay, so we can use the drip or micro irrigation system. All right. Okay, so we can use the PVC pipe or we can use the some iron pipe. That's no problem. All right, and sometimes pipe can be the tape, also means plastic. Tape means it is a flexible. Okay, and emitter we call it emitter, and another name is called emission device. Okay, all right, I will show you now. Okay, this is the system components. Okay, so you can explain from the this side or maybe from the source means water source, and the plant means emission side means the discharging water. So water comes from here through the pipe and release water in the plant or in the soil or in the root zone. Okay, maybe it can come from the pump. So this is the pump. Okay, as I mentioned, this is the pump, because previously I compared sprinkler and micro. Here only the micro. Okay, then filter. What is the filter? This is the filter. We have two types of filter. One is primary filter, another is secondary filter. Okay, then we have some injectors like this. Injector means like this one. Okay, then we have some valves, some gauges and pressure regulators. Okay, like this. So you can monitor what is the water velocity, what is the flow rate, what is the pressure, everything you can monitor. So you need to put it some devices. Okay, so these devices can be smart. So when you say smart irrigation, actually everything is the same, because we have a device. The device we have a manual device, and the device we have a sensor based, and means sensor and controller. So meaning that what is the flow rate we can monitor in the system. Okay, in the display board. Okay, or maybe you can connect with the server, then you can display in your what is happening here, how much flow, how much water pumping, how much is here, how much is here. You just put the like the gate and this thing, this device, then you can monitor from your mobile. This is possible now, but expensive, very expensive. Okay, very expensive. So that's why a smart irrigation system is like this. So all the devices are available. Okay, so this is the control head. We call control head and monitoring. That's why I call control head and monitoring devices. So if you want to know what is the flow rate means, let's say how much water is pumping. So you can provide device here. Okay, all right. If you want to know, okay, how much water is this pipeline, so you have to put the device here, then you can know how much water is coming. Okay, this is called control head and monitoring devices. And okay, water delivery and distribution networks. Water delivery and distribution network. So means how water comes from pump to your field. All right. So this one is, I remove this thing. Okay. Now we can say main line. Main line means This is the pump. It comes to this all along. This is main line until this. Main line means your water from pump to the field. Let's say this is the field. This is the field, and your pump is here. Let's say few kilometers. So you bring the water from here to your field until this. So this is called main line. Okay. Once you come to the main line, then you enter to the field, because this is your field. This is your field. Okay. This is your field. So this is the main line. Then you enter to the field, meaning that like this. You come here, then you enter the field. Meaning that this one. Okay. So this one sometimes we call submain. Okay. Sometimes we call manifold. Okay. Both, but I recommend to say manifold. This one is manifold. Okay. Manifold. But in some books it mentioned as a submain also. I will tell you, I will make you the difference, then you will understand. Okay, just try to know this. Submain, it can say submain or manifold, but main line is pump to the field. Okay, just this line. Okay, then headers. Okay, headers is a difference. So here there is no headers. I'll show you later. Just remember the headers. There is one. Okay, but header is not available here. Another is lateral. Okay, what is the lateral? Lateral means you see the main, I said manifold, this one, and this line. This line means where is your plant? Okay, so this is your plant. Okay, means you grow plant here. Okay, you grow plant here, you plant here, you plant here, you plant here. So this is called row. That is we call row. Is it row to row line? So this is called actually pipeline along the row. So that is called lateral. Okay, all right. Then emission device. Emission device is always on the lateral. It never put here. Emission device on the lateral only. All right. So clear now? Everyone clear this one? Okay. Thank you. So I just remove it. Then I just review it again for your understanding. Okay. Different way. Let's say I have a field. This is the field. Okay, this is the field that you want to grow crop using microirrigation system. All right, so now I just draw like this. Okay, let's say this line. When you say this line is called manifold. Okay, I write here, or maybe okay. Okay, this line is called manifold. So manifold means I can say this one. Okay, manifold. All right. Okay, this is the manifold, and then manifold, and then we have a plant. Is it? Let's say this is the plant. Let's say you planted here, you planted here, you plant here. This is your crop. Okay, this is your crop. So when you have a crop, you plant like this, similar way. Okay, so meaning that plant to plant distance is the same. You have to maintain this one. Okay, so now you have a plant. So now you need to supply the water. So when you need to supply the water, so what you have to do? Then you need to connect the pipe. So just push the connected pipe. So meaning that This is called, just connect the pipe. So this is called lateral, means this pipe. Okay, so this pipe is called lateral. Okay, so now you can see just water. Then you have a source. Let's say this is the source. Here is the pump. Okay, here is the pump. So you want to bring the water from pump to your field. So you can connect the pipeline. Okay, you just connect. So water is coming. So water comes to the pipeline, and then you connect with this here. You can put some gate valve here. If you on, the water will enter here. Then water coming. Then water, you can put the gate valve here also. There are some gate. If you don't have, no problem. So water will come, then water direct enter. But if you want to say, okay, I want to control, you can put the control valve here. Otherwise, you just put one control here only. Once you open, water will enter everywhere like this. Okay, everywhere like this. That is called this. So this is called lateral. Okay, this is called main, and this one is called manifold. Okay, now water is in the pipeline. Now water doesn't come to the crop or soil. So that's why we have what now emitter. Okay, so emitter is installed every plant. Okay, this is the plant, is it? So emitter installed here. Let's say I put the different color. Okay, so emitter installed here. Okay, in this pipeline. Okay, beside the plant. Once you install the emitter, so emitter device is like this. Okay, there are different shape. Okay, so something like this. Once it is connected with the like this lateral, so it's connected with lateral now. Okay, like this. Okay, so water comes and drop water here. Okay, so it irrigates. So this is called emitters, sometimes called dippers, sometimes called micro sprinklers, sometimes called micro jets. We have a different types. Okay, so now you install this. This is the way water comes. So you can see now emitter means emitter connects with the lateral. Okay, this is called emitters or emission device. Okay, and manifold connect the lateral. So meaning that manifold supply water to the lateral and lateral supply water to the emitters, and main line supply water to the manifold. Okay, so here is submains not mentioned. Okay, and headers are not available here. Okay, I'll explain later these two. Okay, so clear now, is it? So clear this one? I was clear. Okay, so now I go to the, I remove this one. Maybe here, or maybe I can go to the next. Okay, here is this. Previous I mentioned the two things. That is what is called header and submain. It is not available here. Okay, look at this picture now. Okay, maybe after this I'll stop. Then we'll start 10:30 or 10:45. Okay. Okay, so this is the pump. So pump is available, and this is the injectors. Okay, for chemicals, fertilizers. We can put different fertilizers here like NPK. We can. Then when you supply the chemicals, we free the tank, then we put the chemicals, different chemicals at different ratio. We can connect with this pipe and then coming. Okay, so this is called injectors. This is a primary filters. It's same like this one. You can see this is the primary filters. This is the injectors. Maybe this one. This is a sand separator or hydro separator. Yeah, either this or the here is okay, no problem. Okay, depending on this, you can normally primary filter. Normally the chemicals. After chemicals is filters. Okay, easily like this. You can see the yeah, this is the chemicals, then then this is the filters, this one filters, because chemicals have some granular material, so it can be some sedimented, so you must have chemical first. Okay, that's a chemical first. If chemical, let's say, it doesn't dilute properly, so the filter will catch it. Okay, it will not allow to come to these pipelines. Okay, that's why injector first, filters. Okay, then you can see the pipeline coming until this is called main line. Okay, now we can see, you can see the small black pipeline here, black pipeline, it connects to. So what I told you that when you have a line, you plant, this is your plant, is it? Sorry, this is your plant, and this is your plant, this is your plant, means your crop. So when you have crop, you put the line, this is called lateral. Okay, lateral. You can see the two lateral connect with small pipeline. This is called header. Sometimes two lateral, sometimes four laterals. You can see 1, 2, 3, 4, and connect with one. This is called header. Then this header connect with this. Okay, so this is called manifold. You can see here, this is a so here we have the manifold. This is the manifold, and connect direct, manifold lateral direct. Okay, this is the one layout. Another layout is, you have a manifold, then let's say you have a lateral like this, you have a lateral like this, you have a lateral like this, then you connect with this one and connect this. Okay, like this, this is a lateral, this is a lateral, and this four connect like this. So meaning that if water enters, this four lateral will get the water. Now you connect with the pipeline. Okay, so there is some advantage for this. Advantage is, let's say you have a small garden, you want to grow here carrot, you want to grow here tomato, you can do it, but you cannot mix. So this way you can do different crop. Okay, this is a good way. All right, it's possible. So this one is called header. Okay, but there is no header here. Okay, that's why header is connected. Actually, header means the one header connects few laterals, maybe 2, maybe 4, maybe 8. Normally most of the cases maximum 8. Okay, like here you can see here 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. Okay, and if you have a control valve like this gate, okay, let's say you want to supply water only here, then you can stop everywhere, all stop, so water will come only here. So that's why you have a control valve, you can see. Okay, so this is the arrangement actually. Okay, this is called, yeah, pump, injectors, filters, main line, then this is your manifold, then manifold to this is a header. If you don't have a header, it's okay, no problem. You remove it header, then you connect direct with the pipe. So meaning that without header now. Okay, this is it. Okay, this is, you can use both system, no problem. Okay. Okay, so now I will like to highlight one more thing. You are still waiting for submain, is it? I know that. Okay, okay, let me explain what is the submain then. Why submain is not mentioned here. Okay, I think I have a one picture. Maybe I go there and show you. It would be easier. How about this? Okay, this one you can see. This one is what? This one is pump, controllers. Controller means injector, filters, those things. Okay, then coming main line, then entering, and this is manifold. Okay, as I mentioned that some books it is called manifold. Actually not, no problem, you can say manifold. Sometimes you can say manifold is also submain. Submain. Why submain? Because this is the main, and after main is there is another pipe is called submain, because main pipe is normally diameter is high like this. After this you have a smaller diameter maybe, so this is called submain. Okay, so but if when I can say submain and manifold is different. Okay, so in this case you can say this one is a submain, also you can say manifold in this case, because this one is a main line and this is a pipeline. This is called submain, but I can say manifold. I prefer manifold. After this is the lateral, this is no problem. And then you can this is your plant, is it? This is no problem. Okay, look back another one. I go to another one. Okay, here you can see the pump. Okay, injectors, filters, then pipeline. Okay, then you have the, okay, this one. Okay, so this one is called header. You know header, why? Because this is the line coming to, this is the main line. This called manifold. This is the manifold. Then manifold connect with this header. Okay, 4 or 5. Okay, okay, I want to show, otherwise I'll draw. Okay, yeah, this is the manifold and this is the lateral. Okay, underground or subground can be. Okay, okay, you can see that these are the emitters. Okay, device, sorry, this one is the filters, many filters type. This is the filter, we have many filters. Okay, I don't know how many thousand, many filters. Okay, I think I come to here, then you can know. Okay, like this one. Okay, I will complete by 5-10 minutes. After this we will start the next session, so I'll explain. You can see here, so this is the one line, then lateral. So this one is called manifold. Okay, this is another type. You see the water, this means water coming, the gate bulb. So this is the line, so this is called manifold. Then this is the lateral. This is the another way. This is the bulb, maybe water coming from the main line. You have a bulb 1, 2. So this is the 1, this is the 1. So you have a 2 manifolds here, 2 manifolds. Okay, then this one is like this. This is the main line coming, and this dot dot means it is underground. The pipe is underground. Okay, something like this. This one. Okay, all right. Like this one. This is the main line. This is the underground dot dot. Okay, so meaning that this one is a manifold, underground manifold, be installed under the soil. Okay, this one on the surface. This one is coming. It can be on the surface or can be maybe sometimes underground, no problem. Okay, and this one you can see with the header. You can see this is the bulb. This is the main line. It is not main line. Main line is something like this. Main line means palm to the field. So this is the main line, and this one is a manifold, and manifold connect with the header. Each header has a 8 lateral. You see 1, 2, 3, 4, 5, 6, 7, 8, and this is called header. Okay, this one. Okay, Okay, this is the emitter, looks like a small device like this. You have a different types. Okay, emitters. These are the emitters. Sometimes like this, sometimes like a tall like this. Okay, you have many other things. Okay, look this one. This one. What is this? This is a pumping, means tank or pump. Water is coming. Water coming to, let's say this one. So it is the field. Okay, and then this one. Okay, so this one is like this, and then there is a valve, there is a valve, there is a valve, means that you can control the water. If you can close here, water will stop here. If you close here, water will stop here. If you open here, water will enter here. So that's why this valve. But this is the different field. You can see this is the field. Okay, if I consider this is the one field, then this line is a manifold, and this line is a lateral. This line is lateral. So meaning that similar like this. This is the plant. Okay, like this. Yeah, this is the manifold. This is the manifold, and this is the lateral. All right, that I mentioned. So here is same like this. This is the manifold. This is the lateral. So this is the manifold. This is the lateral. This is the lateral. Same like another. So it has a 3 fields. 1, 2, 3 fields. So you have a 3 manifolds here. 1, 2, 3. So here is a different fields, and from here to here you have a space. Okay, so meaning that you can grow one crop here, you can grow another crop here, you can grow 3 crops you can grow, or you can grow the same crop. Okay, but different time. Let's say this one you can grow in January, this one you can grow in February, this one you can grow in March. So you can continuously you can get the production. Okay, but if you grow same time, you have to harvest all same time. But this way you can go different times, and you can sell and harvest different time. Okay, so meaning that different manifold. Okay, and this is the okay water line coming. So this is the main line. Okay, then what is the sub line then? Sub main. Okay, so main line is clear, manifold is clear, lateral is clear, header is clear. So now I like to put it the sub line. I'm looking the some empty space where I need to draw. Okay, maybe I can draw here. Okay, just for understanding. What is the sub main? Sub main means, let's say your water source is here. Okay, just 2 minutes I can explain this one. This is water source. This is the water source. So meaning that you have a pump here, and you have area. Let's say you have a one field here, another field is here, another field is here, another field is here. Now you need to supply water all of this field, but one field and another field is far distance. So the same pump, this is a pump. So meaning that you can put the pipeline like this, and then you block here. This is called your main line. Then maybe one pipeline you can bring to the here. Then you can put the here gate valve. So when you need water, you open this valve. So water will come here. So this is called submain. This is called submain. So now you have a 4 field different places. So you can put one submain here, another submain here, another submain here, different submain. So this is called submain. So once you come to the field, then you have this manifold. Okay, that I mentioned before, manifold and lateral. So this is called submain. Submain is usually used when you have a multiple fields in different places. Okay, then We call this called submain. But same thing, let's say this field that I explained just now, like this. But let's say your field is like this, different way. Let's say this is your field. Is the same places, okay, but you have a 3 blocks like this and this, and the water source is here. Then you bring the water here. This is your main line until from here to here. Then you put the pipeline here. This is a manifold. Then you put the lateral. All the field is coming from the same line and going to the east field. This is called, so this is called manifold. But when you have like this structure, means only one field, it is called manifold, and sometimes we also call submain. Okay, but if we have a multiple blocks, let's say this is one block, this is another block, this is another block, okay, but it is a different places, so we need additional pipe like our road network. Okay, we come to the house, then we can go to the different location. So we have a main road, we have a small road, then we have another road, we have another road. So this is the way. So destination is different places. So this is the main road, then this one we can use sub road or sub district, similar like here. Okay, so water source to the, what is the location of the fields? If different places, we use the sub main. Okay, that is the thing. But if field is in one place like this, so normally we don't have sub main. It is a called manifold. Okay, otherwise, if field is organized in one place only, then we can say sub main and manifold is the same, only in this case. But if structure is like this, your field is here, your field is here, your field is here, different location, then this one is called sub main and this one is called manifold, because this is the manifold, then you connect with the lateral. Okay, this is called submain and lateral. Okay, I wish clear. Okay, our video will stop now 10:30. Okay, so maybe we can start 10:45 then. All right, continue, and then I will go more details for the calculation. I think most of the description is correct, finish almost. Then we go for design calculation. Okay, 10:45 then, see you then.